is by leading by example. So leading by example means, trying to help people from the community who are trying to finish their contributions, or they are stuck on a technical problem. They don't know how to continue. We are here to help them finish those contributions, which at the end goal is to help the F# compiler or the editor tooling or any library, to be honest, that you use or your company uses. So yeah, if you want to know more about us, you can visit our website, which is amplifyingfsharp.io. And here you will see all the information that we have. You can, really read a little bit more about who we are, what you can contribute, how you can convince your boss, and, some of the testimonials that the members of Amplifying F# kindly added, sorry. And yeah, you can also see the previous sessions. We have close to more than 40 sessions so far, which is amazing. You can basically learn. You can just go and watch all these amazing sessions where you can learn all about F#, from adding warnings, from improving the editor tooling on Rider, on VS Code, on Visual Studio, iStask, a lot of different stuff, F# analyzers. And today it is my turn, so I will be focusing on trying to fix a compiler bug that has been bothering me for maybe a year or so since I started learning F#. So we will go more in detail with that. But before I do that, I wanted to mention that Amplifying F# is also running another initiative, which is called F# Essentials. This initiative is targeted for people who want to learn F#, who want to know the basics, who is maybe familiar with other languages like JavaScript, C# or PHP or any other language, and they want to get, their hands dirty with F#. And here you can join us every Wednesday for the next 11 weeks, where we'll be diving in some more detail about F#, like pattern matching, compositions, collections, how to organize your code. So yeah, please check the F# Essentials. And yeah, this is in partnership with Ian Russell from the community, which has an amazing book. So please check this out. So yeah, so let's dive into, well, before I do that, the last thing is like how you can join us, how you can be like myself today. So you can go to join us, and on here you will need to just fill out some small details like your name, your company name, what's your time zone, so we can schedule the session in a decent time for everyone. The topic that you want to cover, for example, you want to add a new code fix on Rider or in VS Code that you wanted to have because you have seen that in another languages, and you would like that to have in F#. So you can say that. You can also say, like myself, I want to fix a specific issue. You put the link of the issue on on the repo, on the open source project that you want to contribute, and then tell us a little bit more about the context of what motivates you to fix that issue. It's not only for specific issues. You can also work on a specific project, and if you still don't know, but you say I want to contribute to F#, but I still don't know what I want, but I have these ideas, so we can help you shape those ideas and see what will be the best for you as a newcomer. But yeah, and once you do that, we will schedule a session, and yeah, it will be you on on Fridays, like I will be doing today. But let's go to today's session. So today's session is about improving or enhancing the way that the compiler enforces the attribute targets. So a small example is like you can create custom attributes like I am doing in this screenshot, which is I'm creating a attribute that is going to be only applied to methods. And why is that? Because I'm using attribute targets.method, and this it's going to need to be only used for methods. But of functions in F#, right? And then it cannot be used in a value. So this here today compiles, but it shouldn't, because the reason I just said, you cannot use an attribute that is not it's using the wrong target. And so yeah, I guess before we can continue, it will be good to know, how does these attribute targets are being used in F#. And the short answer is there's not any documentation or any specs in F# that's going to say, okay, saying if you use this target, it needs to be mapped to this in F# and all of that. And so what we'll be doing today is going through the code base on F# and see how we are using the attribute targets today, and then use Fantomas tools to analyze the AST to see the left side of in this case, the left side of the equal, which is the pattern, and then the right side of the equal, that is going to be the expression. But let's first a little bit read about the Microsoft documentation about how can you define your custom attributes. And this is targeted to C#, but the overall documentation for the attribute usage and the attribute targets, it is the same. So right, so if I go to so saying apply the attribute, usage attribute, all right, that's the same for us. That is the same for us. Okay, allow multiple attributes, that's okay. So I just want to know how many options do we have in the attribute target. So let me look for this. And this is an enum, of course. So these are all the attribute targets that that we can define to define a custom attributes in C# and F#. So as you can see here, we have from assembly, class, constructors, delegates, enum, events, fields, generic parameter, interfaces, methods, module parameters, properties, return value, and struct. And I guess for what we are trying to fix today, which is only caring about let values and let binding functions. So we only are going to be looking at the field. That's one of my guesses, and then methods, return value, and maybe the property. So yeah, that's the one that we will need to be looking at. So just a little bit of a side note. If you go to F# to the repo itself, and we look for the number of issues that we have with attribute targets, there are 8 opened issues, and the one that we will be trying to fix today is this one here, which is basically what I just said. But there are more regarding, for example, this one here is one that I wanted to also address at some point if if this session goes in a decent way. I guess I will be able to tackle this as well. But on here, for example, you can use a method target into a type, into a class, which is sorry, no, yes. So yeah, there are some information here, and I think it's help wanted, so it means that it's ready to receive contributions. Right. Okay, cool. So once we kind of know what we what's the issue and what are the targets. I guess next step could be just maybe doing some examples here. Let's value equal to 0, and then let my func, and then parameter, passing a parameter and this. So we have a value and a binding here. And if I go to here and then check this here, just to show how this is going to be, open system. Right, so this is a method. So in theory, Copilot, shut up. So this should be we call fields only, and then I will just take this and put this one here. These are the correct uses, but if I use this one here, this all compiles. Yeah, all compiles, which is not right. Right, so first thing I always do when I enter the compiler is to write a unit test to basically verify that what I'm saying is actually true. So for that, I already went to the attribute to the unit test. So there are two places where you can write unit test in the F# compiler. One is the F# QA place, which is in a folder somewhere that is, really hidden. So I don't like that way, because it is the way that it was. That's the way that you used to write the unit test in the past. But now we have an amazing project called F# compiler component test. So if you want to write if you're adding a fixing a bug or adding a new feature in the compiler, please add the unit test to this project rather than the old place. So here I created a file called attribute targets, which is this, but let me show it. That one there is here. And then here I am going to basically define what will be the right way of calling this. And then on the attribute usage, I'm going to actually use that file to write that. So if I, for example, run this test that targets this specific file, I will expect this to pass as with the version 8, which is the current one, stable. And then I will do the same with a preview version, which is the one that will be for F#9, I believe. Yeah, my machine is a little bit slower, but while this is happening, I will be also talking about something interesting. So this in the compiler will be a breaking change, because existing code will be compiling fine using the wrong attribute targets. So we cannot just add the check, our new check, and just be done with that. We need to add a language feature for that, and I already did that just to save us some time. And if I go to I think it's called Feature, no, it's called language features. Yes, FS, and there is this file called language features FS and FSI, where you can add an entry to this discriminated union saying what is the new feature, what is the preview feature that you're going to try to implement. And here I said enforce attribute targets on functions, and then once you add this, it will be complaining somewhere else, like I want to add this feature to for example in this here to preview. I didn't want to put this. Don't put it in only F#8. Any new feature should be added to the preview part. So when this is done, then it will ask you to also to also write a small text to basically mention about what is this feature about. So what I did is went to it's called fscomp, and on here, if I look for this text here, you will see that I added a new entry, and it's basically saying that this preview feature will enforce attribute targets on functions. This, and then running a terminal command that is in the README. It will basically it will generate the string for you to be used like in here. So once this is done, you can now access to this. You can say if language feature supports this feature in preview, then do this. Else, do what you were doing in the previous version. So going back to our test, this passed, which is normal because it's how it is. This with 8, and the preview as well will pass because we haven't really added the check for the preview. So next step will be to kind of see where in all the immensity of the compiler, where we can start, looking at where we can put that check, where we can check for if it's a function or if it's a value. So I know because I have been contributing for quite some time now. I know that the place in this case will start on check declarations, and then it will go to check expression, just because of the way that the compiler, the phases in the compiler work. So just to give you a little bit of how you can navigate on the compiler. If you go to, in this case, I know that it's a checking, and we know that we can, deduce that it's checking some basically AST or some data structure. So if you go to the checking, you will see a lot of files there, and there are two that are the important ones, and this is the check expression. And on here, I just basically put some breakpoints in places where, for example, it's saying binding check code for all bindings, including let bindings, let recursive bindings, member bindings, and object expression bindings. So this is going to be called for multiple places, but it calls from the places that we care, which is let bindings, let values on modules, and then on classes as well. So this is a good place to be. So if I see where is this call, I see that it is being called from recursive bindings, as it is mentioned in the comment, from non-recurring bindings, and from the object expression bindings, which is something, I guess, when you are defining a member you are overriding or implementing a member on a object expression, that will also be called for that. But we don't care about that at the moment. We will only be focusing on let bindings, okay? So let's, for now, go to the non-recursive bindings. What I'm doing here is basically going up in the hierarchy to see, where this is being used. So next is being called from non-recursive bindings, and this is being called from let bindings. So we are going up in the hierarchy and seeing where is this being used. And on here, I see that check expressions is being so this let binding is being called from two places in check expressions, linear expressions and let bindings. Just to understand a little bit. So this one here is saying TC linear expressions. So Daniel Reeves asks, are these folders the faces of the compiler? I don't think they are faces of the compiler. They are more, placed in the way grouping the functionality on what is the actual behavior of those files. But maybe Florian can give me a hand on that. Do you know, Florian, if these files are the faces exactly of the compiler, or they are just an arbitrary in arbitrary order?
I think there's a bit of an overlap. Like there's a file which will give like the main entry point of the compiler itself, which has like the main one, main two, main three, and wherever those functions end up calling will more or less be separated by folders. But like the parsing, well, the lexing and the parsing might just be like in one set of one folder. So it's not an exact one-to-one relation.
Yeah.
If that answers the question a little bit.
Yeah, I think it does. I mean,
I
to
think
be honest,
if you were to look for like main one, that might be
main
an
one,
interesting. Yeah, main
I haven't
one.
really get into name into that one. So main one, like this.
Yeah, there should be a main one function somewhere exactly.
Okay.
Yeah. And if you look where this is used, so go to the usage. Yeah,
Yeah.
this is actually your
Sounds
compiler.
good.
That will be called from MS Build when you do like a .NET build. And these are like what we consider some of the phases. But this main one does, more than a little bit more than one of the actual, well, more memorable, like theoretical phases, like lexing and parsing is considered as one phase. So it really, it has a bit of an
Interesting.
old distinction. So type checking as well happens in main one, I think. And if you already go into main two, you already have what we call the CCU tunk, which is really the information that the assembly, the public information, the binary that's being created. So main two is called the second phase, but actually already a lot of stuff happened in phase one. So yeah, it's not all one to
There
one.
is a good place to read more about that, and that sorry, I haven't really checked, which is if you go to the I think is the compiler documentation. And in here you have the F# compiler guide, and you can have here, the key folders. I think this is a good place to basically, or this is where I went to actually understand that this is, where I need to start looking into. And this is because it's saying the checking logic. So for me, everything that I do with warnings, errors, and most of that is checking, because that's basically where all that process is happening. Right. Thank you for the question, Damien. Right. So let's go back and see where I was. So, Cuckoo, hopefully you can still see my screen. Yeah, assume so. Perfect. So, yeah, so this is calling TC lead binding. And yeah, as I say, we go, you can just go all the way up. And in this case, where is this being called? This is being called from check declarations, and this is being called from type local binding, and this is being called from a, yeah, this is the one that we're interested. And this is called from a class phase 2 class binding increment. I guess this is when you have a class, and inside of a class you have a let bindings. So this is where this logic is being called. So, but let's really go to where we want it to be and where I know the check is going to be. What I think the check is going to be is here, whereas we are normalizing the binding, and we have enough information at this stage to analyze the left part, the right part, and then also see what is existing, why is this bug happening, basically. So this bug is happening, or this behavior is defined on these allow attribute targets. And on here, what's currently happening is it's only caring about the member flag optional. Opt for the option, yes. And here it's only checking, okay, so if it's a module or member binding, which means this is a let binding that is in a module, or it's an object expression of right binding. Not sure what that is at the moment, but I can maybe guess what is that. And then he's checking the SIM member kind. which is, I guess, what is inside of the class, like a constructor, a property get set, all that stuff, and just setting, okay, this is a constructor, this is an event, a property, and all of that. So we cannot rely on this logic, or I wouldn't modify this logic per se at this stage, because this will be modifying this signature, which is called from another places, and that can get a little bit messy. So what I'm going to do is I'm going to go back to where I was, and on here I'm going to do the something which is, I think, is if do we have access to G dot is this G? Yes, and I think it's support Lang version. Let's see, I got my notes somewhere, so bear with me. So it's G Lang version support feature. So if I do if Lang version, so Writer doesn't really want to give me the IntelliSense, but I guess I can just maybe comment this for now, and it's going to be something like, or I can, yes, support feature, and what I'm going to do here is going to say Lang, so Lang feature dot, and I know that this is going to be the enforce, this one here. All right. So if this, then just for now, let's return this one here as a just so the compiler will be happy. Right. So what we're doing here is basically going to add a switch saying, hey, if you are using the preview version, I want you to use this different logic. If it's not, just do what you were doing before. So that is our first step. So with this, we are safe to to only modify what's going to be on the preview version, and we won't be affecting previous version of the compiler. Right. So how do we want to approach this? I guess when we see the a lead binding on Fantomas, or basically on, let me open a scratch here. So how many different ways of, how many different, I guess, how creative can you get to when you create define the how creative can you get when you basically are typing a value? So I can only think on a couple of them. So this is a value, and this is also a value, I guess. Can also do. So I want some help from the chat. So can you type in the chat like Florian did I guess if you know an extra way of defining a value on on the left side. So what patterns can you add into the left side of the equal? And the right part's a different story, because we can analyze, we know that Sing expression has lambdas, have functions, had match lambdas, has a lot of stuff that it is really complicated. But I'm more interested on the left side of the equal. I'm just maybe trying to cover most of the cases, but maybe some x is equal to none. Is this a valid thing? Maybe not. I don't know. But yeah, for now, I guess I'm going to only cover these two. I got some responses in the chat. Let's have a look. Oh, you are. I didn't expect. I wasn't expecting this one. So right. So so we have X. I guess X will be something defined in something like that. So this is, I guess, just for now, just call file width like that, and Y here maybe can be 1. So this is just want to send this to the interactive to see what is this. Yeah, so where is this file inside and duplicate? Yeah, I got to and Y somewhere. Yeah, sorry. Okay, so yep, that should do it. So this should be a value, I guess. Yes. Okay. Anyway. Okay, one more time. But yeah, that's a good shout. Okay, perfect. So it is a value. Perfect. So int. All right. So this is another one that we need to check. Right. But before we start doing that, I want to find a way to only care about let bindings that are on a module and a class. I don't want to care about members, static members, or anything like that that is inside of a class. So for that, I think I saw a check that they are doing here with the kind. So declaration kind here has a, let's see what it has. So it has module member binding, which is interesting. That's what I want to use, and has class let bindings, which are, they can be static or no. So I only want to care about these two. I want to care about module member binding and class let bindings for now. So let's do that. All right, so if I go back to where I was right here, what I can do is basically just check this for now and say match. So it was deck. Okay, thank you, Copilot. Now, could you suggest something for me or no? Maybe tomorrow. Yes, thank you. So I only going to care about this one here. And then I will be able to only care about class let bindings, and then, no, binding, sorry. And then I will do this. So I know that on here is where we want to do that. So I'm just going to, for now, paste this. And then, again, this logic is just to get me something that will compile. Right, so while this is catching up, another one I think is interesting now that I just realized is what is this? So if I do let foo equal to name of, and then maybe copy field attribute. So we also need to care about name of. Name of is also yeah, so okay. Yes. Oh, and this as well. ID. Oh no, this is a function. Yes, this is a function. Okay, so we don't. Yeah, this will be another check. This is for the other attribute. I got more comments. Let's have a look. let bool function true. Yes, that will be a function. So yeah, that's definitely a good shout. And I think we will need to check that. Right, but I'm now really interested on the left part. So yeah, this is another one. Okay, so let's make some progress and start adding more checks here. So why are you not happy? Because you need to be discarded, because we don't really we will analyze the lead binding and we don't really care if it's it's static or not static. Yeah, for now, that doesn't matter. All right. I guess let's no, for now, let me now do something more interesting, which is let's check if the right expression on the lead binding, the right expression is a function or not. And for that, I think we can start discarding the typical ones that we know. So let's say is right hand side a function? And for that, I think I saw somewhere here that says right hand side. Okay, I saw that somewhere. Here it is, right hand side expression. And this one is a sing expression. So I can say much. Oh, I'm using the wrong thing here, quit. And then I will start by the ones from the top of my head I know, which is the sing expression. You know what? I'm going to let Rida basically complete everything and then discard the ones that I know for a fact that they are not just okay, match values. And please Rida, if my machine wants to do it. All right. So, wow, I love this. All right, dynamic. No. Debug point, no. Interpolated string. Interpolated string. That is another one that we need to check because I think if I do let put 2 and then do and then I don't know, do this for now. This is also a valid bled value. But yeah, I guess if we only check that the left value is a name sim path, we will be safe. But this is also that needs to be in a test. I want to put that in a test. Okay, so for now, remove that fix, remove that fix. Okay, right. Let me do something more like that. Let band is match, so do band, match band, let band, and all of that are really used on computation expressions, and we don't care about them for now, I guess. So let's remove them. Yield from, yes, all of these. No, null as well. Yeah, I don't care about that for now. Well, I think I will be finishing early if I just do it by hand, to be honest. Okay, I will do it in a more quicker way. So parent quotes const. Okay, these are the, oh, sorry, wrong shortcut. Right, so I got the Lambda. So let me, all right, so I got the Lambda. Then I got the match. I got the this one here. All right, so I will say that discard this result, match the lambda, discard this. This is going to be a true for now, and then the rest I'm just going to say false for now. All right. All right, this needs to be indented. And for now, and I think we can maybe add another one, which will be the I think it's called SingExpression.app, which is the application, like in this case, the name of and any function call that you do on the right hand side, that will be a call there. And yes, so for now, let's do with that. Okay. Next step will be to basically maybe, yes, in this case we can do match, and we can match on the path. The path here is so to give a little bit more context, we have the Fantomas tools here, and let me delete just this and have the only the value binding here. Right. Have any comment? No, not yet. Cool. So this is the AST, and here we're interested in the pattern and in the expression. So let binding, we have the head pattern. In this case, is named, and it's X. And then the expression here, it is a constant, and is in this case 0, right? So, and yeah, I can check the ranges, and that is actually what we're interested in. Correct. So as I previously said, is it the X, the name, the sympath name that I'm interested, but I also want to check the tuple one, and I will also check the Florian's one. So I can basically say that this is 2 and 4. So if I do this, if I check the head pattern, this is a tuple or tuple, depending on how you pronounce that, and then this one is a parents. Okay, the parent, correct here. So we have name and we have tuple. So, but we also want to check X, right? No, it's going to be let X equal to 2, so 1, sorry, and then I want to be able to check, I guess, I don't think this checks, this will just tell me what is this. So this is a sympath record with field paths here, and this is just a unit, right? So we have sympath name, we have sympath tuple, and then we have sympath record, correct? So let's out those checks. So I will say that Snasung is sympath name, and then I will, all right, I think I have a message. Wouldn't simp expression be a function only when it's partially applied? Well, it is easy to basically answer that question, because if I go to, for example, X and then say name of, and then just, I guess, put something here. Yes, will that work? There's an application. In this case, I think it will be used for mostly everything. So, for example, if I do fun x dot or fun dot x. X, I am assuming that this will also be an application that has name of and then has as a argument expression has that. So for our case, if we check that is an app is a application, it should be good enough. But we definitely we need to check that in a test and make sure that that is working. All right, so so where it was here. So I can say name, correct. I can say sing path dot tuple, then and then maybe the record. All right, so that will in this case, you know, in here, because we need to return the new attribute targets. So I guess what we can basically say is that if you are here, I guess we can say attribute targets is going to be I want this to be a field. I want this to be a attribute target target dot property. I think I'm missing an extra one here. And the last one we said was attribute targets return value, I think. Attribute targets dot return value. If not, we'll just do what we will be doing here. If I didn't make a typo, this might be it. Yes, perfect. Now the is function check. We can put it here, I guess, when not is right-hand side function. Right. See if everything is green. This is basically, I wouldn't really blame this onto the compiler. This is just my machine. I got a really slow machine that is basically taking ages while I'm sharing the screen and doing all of that. It's always the case. But yeah. Okay, so just to check a little bit our logic. We said that we want to check the language version, right? Okay. Then we say I only care about the member of module bindings and class bindings. Sorry. Sorry, did someone say something? I know.
Sorry.
So, and yep, so here I'm just for now doing a dummy check. I wouldn't really worry about that for now. I just want to basically check the first cases. So on here, I'm basically say if on the right-hand side, there's a lambda, there's a match lambda, there's a, oh, this match, I'm not really sure about this match, because what about if you do something like let foo 3 equal, and then you say match 0 with, and then you say, I don't know, 0 with the 1 is going to be 1, and then you're going to be dot, and then you do it.
Match lambda is actually only going to be with the function keyword. So
so this one here is for the fun like this, basically.
Yes, exactly. That's actually on AST level. What's a match lambda?
All right, nice. But a match one, so this check here, this match will be a normal match, isn't it?
Yes, exactly.
Yeah. So I was.
But
yeah.
Jumping ahead a little bit, I don't think you'll be able to deduce if something is a function purely on the untyped syntax tree. So, do we have any type tree information about the right-hand side here?
So I don't think we have that, but I was wanted to rely on the couple of checks like the SPATs. Where's that? This one here, it's basically if it's this empty, it means there's no arguments on the left-hand side. So there's only a name, and if that is empty, it means that there's nothing next to the pattern on the right-hand side. Sorry, on the left-hand side. And for the right-hand side, the only way I found at the moment is just to check the expression types. So the sim expressions there.
Yeah, but if you have the let equals ID case, ID in itself is a function, so that's
Yeah,
probably
for that, my approach at the moment will be to just basically check the ID check if it's ID because it is a reserved keyword. Uh, like where is this?
yes, but like Martin is saying in the chat, if you do partial application, yeah, you could still get like assign a function.
So you mean full, like my func and then pass something like this and then just do this and then here you do my fund like that.
Yes, exactly.
This is
Like,
an application, yes.
yeah, but AST wise, it's my fund is going to be an idents, so
Yeah. Yeah, that's actually right. Don't have an answer for now for that at the moment.
yeah, which is fine, but I'm just wondering, like, perhaps this check is something that we want to do a little bit later in the type checking phase when the type tree is available. The downside, of course, will be that it might be a lot harder to pinpoint the other pieces back, like what the whether there was an attribute or not, or yeah, not quite sure how easy that will be then.
Yeah, I mean I guess at this point is where we have the left and right information, but there are cases like the one that Martin said that it's basically it is yeah we don't have the information at the moment here. Maybe can exclude that check, but yeah, I don't want to do that. I want to really cover most of the cases here. Okay, Martin, I wonder if we can check on AST at all, take.
Yeah, that's the example we just saw. So
Yeah,
uh,
yep,
makes me wonder if post inference might be like the better place to do the check.
let's have a look. We are here for the right, huh? If I have enough information, I will definitely be up to that. Let's go to the bottom of the file. And so we have bindings here. So we have the check implementation file contents, which is then calling check definitions in module. And we have let binding. Is this a binding? Yes. But what do we have in binding? Binding, type tree. We have the value and the expression. The expression can be expression can be constant, which we know is a value. Reference value, the flag is only relevant if the value is an object model member in the case base calls. So
If you go back one step.
Yep. Let's go back.
Yeah, so the val that probably has the return type of the binding. So
This
yeah,
one.
a little bit higher. Yes.
Uh,
That
so
sort of
we
has
have
this T type, and that will probably be a function type if it's well, that the check's going to be is that a function type or not? And
so we have
if that is a function type and that also has the attribute information where there's a clash, then that's probably where we want to do something.
when you say the attribute information, do you mean, you know, accessing to the basically to that T type function and see if there's an attribute
I
used on
don't
that?
know. The T type is more going to be the return type of the binding. So if you go back again, then maybe not quite sure where the attributes will be stored in this location.
Basically, the advantage of doing the check here is that, you know, I have access to this. I need to be able to, you know, this logic is the one that is defining all the existing behavior. So I'm basically giving a different analysis, I guess, for this preview version based on this. And but yeah, that's a
I
tricky
think
one.
your current point is a little bit too early. The post inference might be a little bit too late, so it's going to be finding the sweet spot of where this is being converted while still having that same information. Do we have a component test where we can just do some little bit of debugging and see how one gets transformed to the other? That might be a little bit insightful to sort of
Yeah,
follow the
definitely.
cookies.
So I have a unit test here that we can actually use. So let's use this one here on the preview version. So right. So if I do you so do we want to put a breakpoints? Do you have a specific place, or is it in the post inference and see where that's, you know, what's the stack trace for that?
Well, post inference might be an interesting one just to see what it contains there. And I guess where we wrote some code would also be an interesting one that we can sort of follow. That's the starting point, and eventually it goes into post inference.
Yep, but correct. So let me put a breakpoint on the binding here. And I am going to do the one that is not using the preview version, so we don't get into the logic. This is interesting. I really like these kind of sessions. Thank you, Martin, for the pointer. That was something that I haven't really considered, to be honest. The application on parsing application is something that that wasn't part of the homework. All right, so what that is doing, I just want to see something. So where is this being called? It's being called on the file contents definition module. This is here. This one here is going to be called here. Who is calling this implementation file contents? I guess this. Is called from the check declaration, a sync start, or an activity start, and I guess this. Yeah, this is where I normally when I normally start all my type checking, all my, you know, investigations from this route. So, mhm. The bug is still running, so bear with me. So we have here the let binding. I saw somewhere let. Ah, yeah, there it is. Then we could check let or do in namespace. That's okay. Right. So this is check declarations, and we are checking the parent. So got the parent. Yeah. So do you want to see something here, or should I go more in depth?
Well, I would assume it happens in let rect bindings. In essence, it's going to normalize everything so the
Yeah.
binding becomes a lambda, and while it's doing that, it eventually gives us typed the type tree information.
Yeah. This is not going to get in. This is going to the previous logic. That's okay. Then it's going to say it's checking the right expression, and it's saying that it's the
Like the overall expression type is already an interesting one. Like if you open that one.
Let me go to the next line so we can basically look at this. Oh, this one?
The other one.
Sorry, yeah, the other one.
Yeah. So
Type
you go to
bar.
the type bar solution. Is there a solution yet?
No.
Yeah. So the moment there's a solution, that will basically give us the answer we're looking for, whether it's a function or not.
So let's keep looking. So we have the all of that. Then we have the attributes. So this is checking the symbol info, which we don't care. Checking this. So also don't care. Is zero method. Zero is for a builder. Nothing. All right, volatile. Nothing. Fix. No, nothing interesting. Inline. Check the pattern on the left-hand side of the binding. Must be a good point to go. Say okay, and this is see this. This is for, but this is not for the expression. This is for something else. Then the pattern here is named. Yeah, that's what we want. What we don't want. Sorry. What is this? Check basics. I don't think.
It's not really the left-hand side that we're interested in, so we.
Yeah, let's continue then. So active pattern, nothing. Active pattern, nothing. The binding,
Now,
no,
now check the rights binding.
sorry.
It says in the comments, now check the
Yeah,
right of the binding. So that's what we're after.
let's basically then put the breakpoint here. Can I put the breakpoint, please? Well, I should put the breakpoint here then. So right hand checked. So where is this use?
It's not computed yet, so we need to put a breakpoint in like the next thing or lower.
Some value,
Yeah,
which
so
is the
yeah, so in this case we know it's a
constant.
constant, but if you open that,
Yeah, it's only related to the constant.
I think if it were still a function, then we might already be able to check that part, but I'm not quite sure.
Oh, so I think the next one is a function. So we can maybe, run it, so run again and see what is the difference here. Well, no, it's going to be the same because it's just this.
Yeah, so it's really a combination of left and right, I guess.
Yeah.
So we need to look down a little. Can you scroll down just a little bit? Okay, so scroll down.
Let's checking if it's fixed. Active pattern. Check out attributes.
Yes, put a breakpoint at the end. That probably tells.
Okay. So val attributes. What do we have here?
It's going to be your custom defined attribute, yes. Field only.
Yep. Then don't care about this. We don't care about this. We might want to check the right-hand side check, which is a constant. Okay.
What's overall pad type?
Over part type, it is solved and it is some string.
But it has a solution. Right now we're doing the constant check, right?
Yep.
Can you run the test where the function is returned, or something that is a function?
Yeah. So for that we need to run it again. Let me go back here. Going back to this attribute target, and for now I'm just going to basically just comment this out and then basically say that x. I know here. Let's basically say func x equal.
No, keep that value. That's fine. Maybe add a type annotation for x. Just make it like an int or something.
Int that takes an int that returns a string.
No, not even that. Just that the whole thing is. I'm a little bit curious what. No, so put parentheses around x. I'm curious if the left-hand side thing will
All right.
give you the,
Yep.
just x, or will it be x to x?
So let's run this. Mhm. Got 2 comments in the chat. Let's see. Thank you, Edgar. No worries, David. Have a lovely one. Thinking further about it, G really is a value with the function type. Do we allow field target? Yes or no? This is not defined in the share spec. Exactly, yeah. It is not defined, it's not basically documented anywhere. Right, let me remove that. And I think we already know what we want to be. So, yep, go further, remove this. Yep. Yes. So what we're interested is in the overall type. Solved type bar. And we have some information here. This is the first time I'm getting into here. So which one? Domain type?
Yeah, I can already see it. So it says t-type underscore fun, and it has like this question mark, a lot of numbers with a 6 to a lot of numbers with a 7. So that basically will tell us that it's a function.
Yeah.
The type-arp solution will be able to.
You just got me there. I don't know what that means, but okay.
Well, it just, it's already going to be inferred that this is a function that's basically good enough.
Nice.
Like the solution, will.
Nice one. And that is for the pattern, which is the left side of the equal, which is good. That's what we can, that's more reliable than the check that I was doing before.
Exactly. So I would just naively try and see what is in this overall typar, if it has a solution, and run all that, run your language version thing. And if that all aligns, then let's just say, whatever warning you were about to raise. Or
Yep, definitely. No, it's just the only thing we need to figure out is like we are basically really just basically let me check one thing, and I think with this we can call it for a day. So this here is going to be assigned here, and I need to check where is this attribute target is going to be used. So this attribute target is used after. So yeah, it's actually we are lucky that it's going to be running after. So I can just basically rely on this. If I do, for example, yeah, I know what you mean. So for example, I need to let me put some notes here. Check for
not
the
not really there. I think the overall path will not be solved at that point where your comment is, because it still needs to do the right hand side.
I mean, I was just checking. This one here is you mean because this needs to be called somewhere. Where is this called?
There's some mutable state happening in there
Wow,
when it
yeah.
comes to the solution. So it's just I would write before the return value, do the check there for now, or write the note there.
Yeah, the only problem is that the attribute target that is passing to the checking is we are really past that. Check the
Well, you can do some of the checks earlier and then
Yeah, I
just say
mean,
some sort of a boolean and then do the check there and see if all things align.
right, let me exactly check this. The type R. And solution. What more was that? So check the overall type R solution. And
If it's a function type and then based on what your attribute values was, that's and the language version, all those things in combination will tell you enough whether you want to raise a warning or not.
con nation will allow me us to define the new or to override let's call attribute targets for a field a property and a return value. Right, that was a really good shout out. Thank you very much. And I think I have some work, some homework to do. But just to show you a little bit that I did some checks. So I did run some unit tests on the check that I did before, just to make sure that we could cover most of the cases. So there's a PR on the compiler that is let me check with my name. This one here, and I basically cover most of the cases already here. So there's also this case here that is also, what do you say this is? This is a function or this is a value? Because that is still, that's something that is used for the resumable code that is a typed, I don't know how to call that, generic. Well, I mean,
a generic value, it seems.
yeah, but it is considered as a function, I think. And the only thing, I just said that because if I look for resumable, I think call is resumable code. And I don't think it's going to appear here, but if I go to, oh, just put everything like, this is the one, use resumable code. That's the one I was looking at. No, and non-include items.
Oh, you have too much underscores at the start.
And two. This to me is doing something. This is defined as a method. And I thought that was a value, but it seems like that is considered a method. So yeah, I also need to make sure that I cover this as a cool. Yep, that shows me a lot of. I made a typo here, so I don't even going to bother to to write that properly. But anyway, okay. So that was awesome. I learned a little bit more, and that's also things. Cool, everyone. I think we know the problem. We kind of try to implement a solution that was good for many cases, but not really good for, it's not going to cover partial applications and all of that. And thankfully I got some pointers from Martin and Florian. So yep, I will be back in the show maybe in a couple of weeks with a better version, and then we can, update the PR, and hopefully this will be fixed. But yeah, that's it for me this week. If you have any question, please let me know. If not, I will end the stream. Going 1, going 2, going 3.